Hello friends, hope you're doing well. Welcome to the 8th practice set of the SAT series. In this session, we are going to specifically focus on exponents and radicals. Okay, so let's get started here. Our first question, cube root of 3y square times cube root of 9y, right? Now, since both of these terms are cube roots, so we can actually combine them, instead of having two separate cube roots, we can write it as a single term, a single cube root, right? So 3y square times 9y, correct? We are able to do that because both of these were cube roots. If they were not the same roots, then we would not have been able to do this, right? But in this case, we are able to do. Now, we can multiply the terms inside. 3 times 9 is 27, and y squared times y is like y to the power of 1, right? And we know that when we are multiplying two terms with the same base, the powers get added, right? So this will become y cube. And then we can take the cube root of this term and the cube root of this term. Cube root of 27 is 3 because 3 times 3 times 3 is 27, right? So straightforward. So 3 comes out and the cube root of y cube is y. So the answer is 3y. Again, pretty straightforward question here. Multiplication of two cube roots, we combined them into a single term, and then we took the cube root of the number as well as the variable. Question number 2. Fourth root of 3x square times fourth root of 27x square. Again, very similar to the previous question. Both of these terms are the same root. This is also the fourth root and this is also the fourth root, so we can combine them and we can write it as 3x square times 27x square, right? We can simplify the term inside the fourth root. So 3 times 27 is 81. X square times x square again would be, we got to add the power, so 2 plus 2 is 4, so it will be x to the power of 4. And then we can take the fourth root of 81 and the fourth root of x to the power of 4. In this case, the fourth root of 81 is 3 because 3 times 3 times 3 times 3 is 81. So we get 3 outside, and the fourth root of x to the power 4 is x. So again, the answer in this case is 3x. Again, pretty straightforward questions. Same root, so we can combine them and then take the fourth root or whatever root we have to do. Question number 3. Square root of 139 plus square root of 41, everything combined, multiplied with square root of 139 minus square root of 41. Correct? So when we see something like this, obviously we can use the FOIL method and we can multiply each one of those terms. But then if we really look a little closer, this is of the form of a plus b times a minus b, right? And we know from difference of squares, right? So difference of squares, we know that a plus b times a minus b is nothing but a square minus b square, correct? And obviously the question follows this pattern here. So the multiplication of this would be nothing but square root of 139 whole square minus square root of 41 whole square, right? Square root of 139, this is our a, correct? This is our a and this is our b, correct? When we look in terms of the difference of squares, square root of 139 square is nothing but 139. So this is 139 minus 41, which is equal to 98. So the value of this is nothing but 98. Again, as I said, we could have done the FOIL method, but it's straightforward to use the difference of squares. A plus b times a minus b is equal to a square minus b square, and we get 98. Question number 4. So we have to simplify this expression here. It looks a very tedious and a messy expression. 2hj square k to the power of minus 2 times h to the power of 4 j to the power of minus 1 k to the power of 4 everything to the power of 0 divided by this term, right? Now, actually speaking, it's pretty straightforward. Why? Because anything to the power of 0, right? Anything to the power of 0 is 1. So it doesn't matter if we have such a big expression like this, correct? Because this whole is to the power of 0, so that becomes 1. So the point I'm trying to make is that we got to be very clear that anything to the power of 0 is 1, right? This anything could be as complex as this or whatever, but anything to the power of 0 is 1. So the numerator becomes 1, right? And then we have 2h to the power of minus 3, j to the power of minus 4, and k to the power of minus 2. And if the question says that we need to reduce the exponents to the positive side, right? We need to simplify this such that we have only positive exponents. If that's the question, then as we see, each of these exponents are negative, so we can take the reciprocal or basically bring them to the numerator so that their powers will become positive. I mean, 2 will still be in the denominator, right? So this will essentially become, this goes up, so it becomes h to the power of 3, j to the power of 4, k to the power of 2 over 2. So this is our reduced form of this expression, right? Again, just to reiterate, two concepts here mainly. Anything to the power of 0 is 1. So this numerator becomes 1, denominator is as it is, and if we have to make the exponents positive, then we have to take those reciprocals, right? The exponents become positive. In this case, each of these exponents are negative and all these terms are in the denominator. So we move them up so that these powers become positive. So h cubed, j to the power of 4, k square divided by 2. That's the reduced form of this. Next question. If x to the power of 3 over 5 is equal to 8, find the value of x. Okay. Now the first thing which comes to our mind is that if we can put the left side and the right side to the power of 5 by 3, right? And we'll talk about why. So let's say we do this. So we take the power of 5 by 3 on the left side, and we also take the power of 5 by 3 on the right side. Correct? We're doing the same operation on left and right side, so that's fine, right? Because if this is equal to this, then this guy to the power of 5 by 3 should also be equal to this guy to the power of 5 by 3, right? The reason why we're doing that is that obviously because we have to find x, and we know that in such a situation the powers get multiplied. So when 3 by 5 will be multiplied with 5 by 3, right? So 3 by 5 times 5 by 3 will be equal to 1, correct? So we will get x to the power of 1 or x, which is what we are looking for, right? So this becomes x to the power of 1, or essentially x, and that is equal to 8 to the power of 5 by 3, correct? Now, in all such type of questions, what we have to do is that we have to rewrite the base in such a way that we can get a power of 3. Let's see. So we know that 8 is equal to 2 times 2 times 2, correct? Or 2 to the power of 3, right? So instead of 8, we can write 2 to the power of 3. So this will become 2 to the power of 3 to the power of 5 by 3, correct? Instead of 8, we are writing 2 to the power of 3, correct? Now the powers get multiplied. So 3 times 5 by 3 is nothing but 5. So this will be 2 to the power of 5. And what is 2 to the power of 5? 2 times 2 times 2 times 2 times 2, which is equal to 32. Correct? So 32 is the value of x. Again, just to quickly reiterate, when we saw this question, we took the power of 5 by 3 on both sides because that gives an opportunity for us to cancel these powers and to get x, right? That's the first step. Now on the right side, when we see 8 to the power of 5 by 3, we have to think of rewriting 8 in terms of 2 to the power of 3. Why? Because then these powers will again get multiplied and this 3 will get cancelled out with this 3 and we will be left with 2 to the power of 5, which we can easily compute, which comes out to be 32 in this case. Question number 6. If 2 to the power of 2a times 2 to the power of 2b is equal to 16, we have to find the value of a plus b, right? Now, if you look on the left side, the bases are same, right? And we know that when we are multiplying two terms with the same base, the powers get added, right? So we know that a to the power of m times a to the power of n is equal to a to the power of m plus n, right? We know that. The powers get added when we are multiplying two terms with the same base. Here the base is same, 2 and 2, so obviously we can add the powers. So the left side becomes 2 to the power of 2a plus 2b. Correct? Now we can take 2 common here. So this will become 2 to the power of 2 and a plus b. Correct? So we have been able to reduce it to this form. The right side is 16. Now on the left side the base is 2. So we can think of writing 16 in terms of base 2, and we know that 16 is nothing but 2 to the power of 4, right? So this is nothing but 2 to the power of 4. 2 to the power of 4, right? So basically the base here is 2 and the base here also is 2. If the two sides are equal with the same base, it means that their exponents would also have to be the same, right? Because the bases are same, so the exponent also have to be the same, only then the two sides can be same. So what it gives us is that 2 times a plus b is equal to 4, or a plus b is equal to 2, because you divide by 2 here and you divide by 2 here, and you get a plus b equal to 2, which is what they were asking for. Just to quickly reiterate, right, when we saw this question, the bases are same, so we added the powers. We are interested in a plus b, so we can think about taking 2 common, because that gives us this thing which we are looking for. The base is 2 here, so we reduce the right side also in terms of base of 2. It came out to be 2 to the power of 4 in this case. These powers have to be the same because the bases are same. So twice of a plus b is equal to 4, a plus b equal to 2. Next question. If a to the power of x minus 3 is equal to 16 to the power of 4 minus x, we have to find the value of x, correct? So very similar to the last question, right? All we do in such type of questions is that we make the same bases, right? We make both the left side and the right side to have the same base, because once the bases are same, then their exponents will also have to be equal if the two sides have to be equal. That's the whole concept, right? Now we got to think that what could be the common base. Obviously 2, because 2 to the power of 3 is 8 and 2 to the power of 4 is 16. So 2 can be our common base, right? So we can write it as 2 to the power of 3 to the power of x minus 3, right? We are not changing the question, we are just rewriting 8 as 2 to the power of 3. This x minus 3 is flowing down as is, right? Is equal to 2 to the power of 4 to the power of 4 minus x, correct? Now the powers get multiplied, right, we know. So it will become 2 to the power of 3x minus 9. And on the right side, it will become 2 to the power of 16 minus 4x, correct? Now these two sides are same and the bases are same, then the powers also have to be the same. So this power will have to be equal to this power, right? So we say 3x minus 9 is equal to 16 minus 4x, or we bring this guy here and this guy here, so it becomes 7x is equal to 25, or x is equal to 25 over 7. So the value of x is 25 over 7. Again, pretty straightforward questions. We are just making the same bases on both the sides and equating the powers to get what we are looking for. Let's take my last question here. So we have a function gx which varies as we see on the board, right? For the value of x as 0, the value of the function gx is 25.5. They've given us some more points here. So when x is 1, the value of gx is 15.3 when x is 2, the value of gx is 9.8, and so on, and the graph is going like this, and we have to select the right option, correct? So obviously they have given us some points, so we can plug in some points and try to eliminate the options, right? But we don't need to necessarily do that, right? We can be a little smarter, right? We can definitely put the value of x equal to 0 and see. So for x equal to 0, the value of gx is 25.5, correct? So let's see that which of those options give us the value of gx as 25.5 for x equal to 0. So when we put x equal to 0 here, right, anything to the power of 0 is 1. So this guy becomes 1. 1 times 0.6 is 0.6. So A does not give us 25.5 when x is 0. So this is ruled out, right? Let's go to B. When we put x equal to 0, this guy becomes 1 because anything to the power of 0, right? So what we need to remember is that anything to the power of 0 is 1. Right? So this becomes 1. 1 times 25.5 is 25.5. So B does give the value of the function as 25.5 when x is 0. So this could be an option, right? So this could be an option. When we look at this again with the same logic, when x is 0, this gives us 6.12, which is not what we are looking for. We are looking for 25.5. So this is ruled out. And when we put x equal to 0, it gives us 25.5. So this could also be an option, right? So these two are eliminated, right? And between B and D, we have to choose one. Now what we see in this graph is that as the value of x is increasing, gx is going towards 0, correct? So as x is increasing, gx is going down, correct? Let's look between B and D. As x increases here, this value becomes smaller and smaller, and hence the multiplication of this also becomes smaller and smaller, right? But whereas in D, as we increase x, this value also increases, and this times this will also be increasing, hence this cannot be the solution, because the value of gx has to go down as the x is increasing, hence B is the right answer. Folks, hopefully you liked the video, and hopefully it gave you a good perspective of the radicals and exponents and the typical questions which we can expect in SAT on these topics. Again, this is not a very tough topic, but if we get our concepts clear, we can easily do them. Keep practicing. In case of any questions, please do feel free to reach out to us at info.mathletes@gmail.com. See you in the next session.